title of mine, my IEP is called Frozen Blaze, which I thought was a really neat way of saying freezing different things in the freezer and scratching them against stuff. Anywho, so for this experiment, my first hypothesis was because, you know, we work every day with ice. We put it in our drinks, you know, we see it outside when it's snowing, not right now. But, so ice, I've been scratched by ice before, and it hurts. So I figured that ice is a pretty sharp thing. So my hypothesis was, out of the 5 groups I tested, water being one of them, ice would be the hardest. So my procedure for testing this hardness was to freeze samples in a freezer for 4 hours. There are constants there. Temperature of the freezer was constant. The 4 hours were constant. I used the same cups for each of these things, so the same type of cup, and they were graduated. So I put 10 milliliters of each substance in there. The next thing, I removed the samples I had from the freezer when they were frozen, and I scratched them against different objects I had at my disposal. I had my fingernail, which is a 2.5 on the most hardness scale, and then I had a penny, which is a 3, and then harder objects were glass, which is about a 5.5, and I think ceramic was like a 7. So I wasn't expecting anything to scratch ceramic, but who knows. And so if a frozen substance could scratch one item, then it could go on to the next one. So if it could scratch the fingernail, then I said, okay, that's fine, you get to go to the penny now. It was almost like a kind of a contest. So you need to be the best at scratching stuff. So the samples I tested were, you have water. Water is a common thing you see every day, we drink every day, it's good. You have salt water, which is something we don't drink every day. And Mr. Clean, which is a very good thing to clean your house, and I figured I should throw non-edible chemical into the mix. And white vinegar, I didn't use Heinz vinegar, but that's the picture I got. It's the same thing, distilled white vinegar. And corn oil, which I had at the bottom with no picture, and I actually have a reason for that. Anywho, I'll say that in a second. This graph shows, after my experiment, the minimum hardness, minimum meaning it's the lowest it could be, of each of these. Water, when frozen, of course, in ice, was a 2.5 because it could scratch the fingernail, but it could not scratch the penny. Acetic acid, however, the vinegar, was able to scratch the penny, but couldn't go on to scratch the glass, the ceramic. So you can see that's the minimum hardness right there. However, the salt water, corn syrup, and Mr. Clean didn't scratch the fingernail whatsoever. This graph shows the hardest thing that any of the objects could scratch, the penny. As you can see, the water, salt water, corn syrup, and Mr. Clean had no effect on the penny. Hence all the zeros. But you can see on the 4th trial, acetic acid actually was able to scratch the penny. So that meant it was good. And it's a candidate for the next one, but it could not pass because it couldn't scratch glass or ceramic. So the results were, of course, the winner was acetic acid. Yes, my friends, acetic acid was the hardest in this experiment. And my conclusions to why vinegar won, the basic reason for water is that it could not scratch the penny. That's kind of the obvious one. But the other substances I froze, they didn't scratch the fingernail at all. That's because corn oil, when I froze it, turned into a slushy. It was just slush. It didn't freeze at all. There was no way it would scratch anything. We tried, it just went bleh. It just moved all over the stuff. Mr. Clean turned into kind of a waxy substance, so it really wouldn't scratch, it just kind of rubbed off. And salt water got kind of crumbly, and that was just, I think, because salt will lower the freezing temperature for the water, my dad told me, so that's probably why it was a little crumbly. So I don't think anything crumbly could exactly scratch a fingernail or a penny. So my conclusion for this experiment is white vinegar hardens the most while freezing, which may be due to, I'm sorry, I misspelled chemical, structure. Take a look at the 2 hardest substances of this experiment. We have water, which is H2O, and then vinegar, which is CH3. Yeah, I'm not going to say the whole thing. But my hypothesis for this, and I will have to look further into this. I couldn't find anything here, actually. They didn't have much on this. But my hypothesis is that when it freezes, when it freezes, water turns, it turns into ice, and it's good and stable. But vinegar has more like elements to work with, more bonds to fill. So I think maybe vinegar has more of a kind of stable foundation there for ice. All right, thank you very much for listening to me, and I hope you enjoy the rest of it.
Can you go back one more, Patrick? Just go back one.
Yeah.
Patrick's very close to the answer here. The answer is that take a look at the shape of water versus the shape of the vinegar. Water is polar, water is polar while the other ones are non-polar. And that polarity adds stability. And so you don't get that in salt water because the polarity of the water is actually compromised by the chlorines and the sodiums taking up space. So the water becomes more random oriented, and crumbly is a good way of describing it. It looks, they call it, like gravelly. Frozen, it doesn't melt, I'm sorry, it doesn't freeze smooth, it freezes like gravel. And the reason why is because the sodium and chlorides are taking up the space that would normally look like that above Bing and Miles. All right.